So in the last section, we talked about how to solve an exponential function, and most of the time it was done through some sort of mental math. Like, for example, 2 to the x power equals 8. 2 to the what power equals 8? Well, that would be 2 to the third power equals 8, because 2 times 2 is 4, and then when you multiply it times a third 2, that would be 8. So we would just mentally say that x equals 3. 2 to the x power equals 16, well, that would be x equal to 4, because mentally we could figure out that 2 to the fourth power is 16. But what about a question like 2 to the x power equals 12? It's got to be larger than 3, but it's got to be smaller than 4, which means it's going to be possibly a fraction or a decimal in between 3 and 4. It doesn't necessarily mean it's exactly 3.5, because 2 to the 3.5 power, if you have a calculator handy, is approximately 11.3 and not exactly 12. So that's why what we're going to be doing, what we're doing for the next several days, is talk about logarithms. So as we're talking about logarithms, think about this question, 2 to the x power equals 12, because the ultimate goal is going to be able to solve any exponential equation and not just those that we can solve by mental math. So today what we're going to practice is just simply relating logarithms to exponents and exponents to logarithms. So you can see over here on this side, it says b to the y power equals x. That is an exponential function. We can translate an exponential function to a logarithmic function by, if you can follow the arrows here, that notice that the base of the exponent is the same as the base of the logarithm right there. So you can see where the b's are. You can see that the exponent in the exponential function, there I just dotted it in with a y, is the same with a red, is what the logarithm function equals. And you can see that the answer to an exponential function is actually what you're trying to find the logarithm of. So for example, down there it says that if log base 3 of 27 equals y, then another way of rewriting that would be 3 to the y power equals 27. So again, notice that the base of the logarithm is the same as the base of the exponential function. And then notice that the answer to the logarithm, the y, is the exponent of the exponential function. And that the answer to the exponential function is what you're trying to find the logarithm of. So try to follow those patterns as we do these examples down below. So, example number 1, just write each exponential, or write each equation in exponential form. So log base 2 of 8 equals 3. So to write that as an exponent, the base of the log is 2, so that's going to be the base of the exponent. The exponent is the 3, and it equals 8. On example B, to write that as an exponential, so the log is in base 4, so we would write 4 as the base of our exponential function. The exponent is the negative 4, and that equals 1 over 256, what we're trying to find the log of. And recall that negative exponents are the reciprocal exponent, so 4 to the negative 4 power actually means 1 over 4 to the positive 4 power. And since 4 to the positive 4 power equals 256, that means 4 to the negative 4 power must equal 1 over 256. We can also go the other direction. We can take an exponential function, write it as a logarithmic function. So 15 to the third power equals 3,375. Since that's a base of 15 in the exponential function, we will use a log of base 15 of 3,375, and the answer is the exponent, 3. If you have a Casio calculator, you can verify this by typing in log base 15 of 3,375, hitting the enter button or the equals button, and it will say that it equals 3. Part B, same situation. Pause the video if you want to try to follow along before I give you the answer. That would be log, and since the base of the exponent is 4, it will be a log base 4. The answer to the exponential function is what we're trying to find the log of 2, and that equals 1/2. And this is a good time to talk about what does it mean to have a log of base, or excuse me, not a log of base 1/2, but what does it mean to have a exponent of base 1/2? What does that really mean? What that really means is the top number is the exponent, but the bottom number is the root. So half powers, whoops, that's the wrong one. Half powers are square roots. Half powers are square roots, and that's going to be important coming up with a few questions coming up next. So now we're going to evaluate logarithmic expressions. So it says to evaluate log base 16 equals 4. So the question what you're going to be asking yourself is going to be 16 to what power equals 4? 16 to what power equals 4? So think about that for a second. How can you get from a base 16 to equal to 4? What would you have to do? Here's a little hint. If I scroll back up here, remember that half powers are square roots. Half powers are your square roots. So what's the square root of 16? Well, the square root of 16 is 4. Therefore, the answer to this question would be 1/2. 16, log base 16 of 4 equals 1/2 because 16 to the half power equals 4. That's the question that you're trying to answer. Let's do a couple more. Evaluating expression, log base 3 of 81. So the question that you're answering is 3 to what power equals 81? 3 to what power equals 81? Well, 3 times 3 is 9, so that's 3 to the second power. 3 to the third power is 27. 3 to the fourth power is 81. Therefore, the answer to this would be 4. In 3b, it says log base 1/2 equals 256. So what question would you be trying to answer? You'd be trying to answer 1/2 to what power equals 256? 1/2 to what power equals 256? Well, that might take some thinking. How can you get from a half power to a 256? Well, remember that we have negative exponents. Negative exponents are the reciprocal exponents. So the answer is going to be a negative. But negative what? Well, 2 to the 8th power happens to be 256. So since it's a half power or half base, 1/2 to the negative 8 power would give you a 256. So the answer is negative 8. Okay, so that's about the first half of what we're going to do. The second half involves looking at graphs. Now, I am not going to make you do hand graphs, but I am going to make you look at graphs using Desmos. So if you have your computer handy, you would go to desmos.com. On Desmos, you would do the log base 2 of x. So if you typed in log base 2 of x, you would see a graph that looks very similar to this. So notice that to the right side, it is starting to flatten out a little bit. And it does continue to increase, but it gets flatter and flatter and flatter. As we get to the low side here, notice it looks like it's touching the y-axis, but if we zoom in a little bit closer, you can see it really isn't. It is actually not touching the y-axis. And as we go down further, it looks like maybe it does start touching the y-axis, but then as we zoom in a little bit closer, you see it is really not touching the y-axis. That's because in this case, the y-axis is an asymptote. It will approach that number, but we'll never actually reach it. So why is the y-axis an asymptote? So let's think about what the question is asking us to figure out. For the graph to touch the y-axis, that means x would have to equal 0. So if we translated y equals log base 2 of x into an exponential function, the question we would be answering would be 2 to what power, or 2 to the y power, equals x. In other words, 2 to the y power equals, if to touch the y-axis, it would have to have an x value of 0. So 2 to what power equals 0? And the answer is there's nothing in the real number system that will make that a true sentence, because if y is any positive number, it'll just make the answer larger. If y is a negative number, it just makes it a very small fraction. And remember, even if y is 0, if we have 2 to the 0 power, anything to the 0 power equals 1. So there is nothing that will make that a true sentence. Therefore, it can never touch the y-axis. So that's why, and because x can never be 0. So that's why the y-axis is an asymptote. Going to finish up with a real-world situation that involves logarithms. Logarithms are on the Richter scale is on a logarithmic scale in dealing with earthquakes. Some people get the logarithmic scale or the Richter scale confused because they don't quite understand a logarithmic scale. But basically, with the Richter scale, every magnitude is actually 10 times stronger than the previous magnitude. So if you have a Richter scale of 5 earthquake, when you compare that to a Richter scale 4 earthquake, the 5 is actually 10 times more powerful than the 4. And when you compare a 4 to a 3, the 4 is 10 times more powerful than a 3. So when you compare a 5 to a 3, a 5 to a 3 is 10 times more powerful and 10 times more powerful, so that becomes 10 times 10, which is actually 100 times more powerful when you compare a 5 to a 3. So it's not just a little bit more powerful, as some people believe. It's actually 100 times more powerful. And if you continue on, if you went to a Richter scale 6, that's 10 times more powerful than a 5. So when you compare a 6 to a 3, that's actually 1,000 times more powerful. So that's how the Richter scale works. So what this question asks us to do is, it explains the Richter scale. It says that the Richter scale measures, let's try that again. Richter scale measures earthquakes intensity. The increase in intensity from between each number is 10 times. For example, an earthquake with a rating of 7 is 10 times more intense than one measuring 6. The intensity of an earthquake can be modeled by y equals 10 to the x minus 1, where x is the Richter scale rating. So this part says use the information at the left to find an intensity in the strongest recorded earthquake in the United States. So you can't see the information on the left because it got cut off, but the strongest recorded earthquake in the United States was a Richter scale 9.2. So to measure the intensity, we would use the formula they gave us, y equals 10 to the x minus 1 power. And so that would be y equals 10 to the 9.2 minus 1 power, or 10 to the 8.2 power. And using a scientific calculator, you could see that 10 to the 8.2 power would be approximately equal to 158,489,319.2. So that is a very intense earthquake, and the intensity is used to not necessarily measure or compare the earthquakes of whole number magnitude, but they can use the intensities and using this method to compare earthquakes of magnitudes that are not whole numbers like 9.2.